Hello and welcome back to this channel once again. In today's video, we are going to focus on even, odd, periodic functions and all of that. So let's begin with even functions. Now a function is said to be even if f of negative x is equal to f of x. A function is said to be even if f of negative x is equal to f of x. Now what this primarily means is that if you should substitute negative x in place of x in that function, then you are going to get the original function back. So let's try an example. Let's say we have f of x equals x squared. Now let's substitute negative x in place of x in this function. So we have f of negative x. Now wherever we see x, we are going to replace that with negative x. So we have f of negative x equals negative x squared. Now let's simplify this. So this becomes x squared, and that is f of negative x. Remember that x squared is equal to f of x, therefore we can replace x squared with f of x. Therefore we have f of negative x equals f of x. Now since f of negative x is equal to f of x, then we say that the function f of x equals x squared is an even function. Now let's try another example. Given that f of x is equal to 3x exponent 4 plus 2x squared plus 1. Now let's try to substitute a negative x in place of x in this function to see if this function is even. So we say that let x equals negative x. In that case, f of negative x is equal to 3 times negative x exponent 4 plus 2 times negative x square and then plus 1. Now let's simplify this. So we have 3 times. Now if you have negative x exponent 4, then that is equal to negative x times negative x times negative x times negative x. Now negative x times negative x, that is x squared, and then negative x times negative x is also x squared. So x squared times x squared is x exponent 4. So negative x exponent 4 becomes x exponent 4. So that is 3x exponent 4, and then plus negative x squared is x squared. So times 2, we have 2x squared plus 1. Now you realize that this expression is what we have as f of x. Therefore you realize that f of negative x is equal to f of x. Therefore f of x equals 3x exponent 4 plus 2x squared plus 1 is an even function. Now one way to realize that such a function is an even function is that you want to focus on the exponent of all the x's in this function. Now if all the exponents of x in this function is even, then it means that the function is going to be an even function. Now if some of the exponents of x in the function are even and others are odd, then the function cannot be an even function. However, if all the exponents of x in the function are even, then regardless of the coefficients of x exponent 4, x exponent 2, and even the constant, the function is going to be an even function. So now let's move on to an odd function. Now a function is said to be odd if f of negative x is equal to negative f of x. A function is odd if f of negative x is equal to negative f of x. Now what this primarily means is that if you should plug in negative x in the function in place of x, then you are going to get the exact opposite of the original function. Or better still, all the signs in the original function are going to be switched. Now let's take a typical example. That is the function f of x equals x. Now let's substitute negative x in place of x. So we are going to put negative x wherever we see x in the function. So f of negative x is equal to negative x. Now you realize that f of x is equal to x, so we can simplify this as f of negative x equals negative f of x. Now since f of negative x is equal to negative f of x, then it follows that the function f of x equals x is an odd function. You also realize that the sign in this function changed or is switched. Here we had a positive x, and then here we have a negative x. So once the sign or the signs in the function switched, it means that that is an odd function. Let's try another example. That is f of x equals negative x cubed plus 2x. So let x equals negative x. We have f of negative x equals negative into brackets negative x cubed plus 2 times negative x. So we have negative into bracket negative x cubed becomes negative x cubed, and then 2 times negative x is negative 2x. So we multiply negative 1 by negative x cubed, and then we have x exponent 3 and then minus 2x. Now looking at this expression, you realize that this is the exact opposite of f of x. Here we have the sign to be negative, this is positive, we have here to be positive, and this is negative. So since all the signs in the function changed or switched, it means that this is an odd function. Now better still, we can factor out negative 1, so that inside of this bracket we have negative x cubed plus 2x, so that what's in the bracket is exactly what we have as f of x. Then we say that negative 1 times f of x is the same as negative f of x. Therefore, since f of negative x is equal to negative f of x, it means that f of x, which is equal to negative x cubed plus 2x, is an odd function. Now the graph of an even function is symmetric about the y-axis. Now what this primarily means is that if you should fold the graph vertically along the y-axis, what you realize is that the graph folds onto itself. So for an even function, if you have an even function, let's say the function y equals x squared, or better still f of x equals x squared. So this is how the graph y equals x squared looks like. You have this to be the y-axis, the x-axis, and this is the graph of f of x, or better still y equals x squared. Now we are going to fold the graph vertically along the y-axis, that is from the left to the right or from the right to the left. So if we should do that, then we are going to have something like this. So this is the y-axis, and then this is going to fold onto this. So this is what we have as the x-axis, and then we are going to have this part of the graph, and then this part of the graph is going to fold on this part. So that's also going to be something like this. It's going to fold on it, and once the graph is able to fold on itself, it means that this function is an even function. So for an even function, its graph is symmetric about the y-axis. That is, if you fold the graph along the y-axis from left to right or right to left, then the graph is going to fold onto itself. Now, what about an odd function? Now, an odd function is symmetric about the origin. That is, if you should fold the graph along the y-axis and then along the x-axis, the graph is going to fold onto itself. Or better still, if you should fold it first along the x-axis and then along the y-axis, the graph folds on itself. Now let's use this as an example. That is the function y equals x. So this is y-axis, x-axis, and this is the graph of y equals x. Now first of all, let's fold the graph along the y-axis. So if you should fold the graph along the y-axis, this is the y-axis. Then we are going to have this as the x-axis. This part is going to fold onto this part. And then first we have the positive side, and then this negative side is seen here. So this is how the graph is going to look like after folding it along the y-axis, and then you want to fold it about the x-axis. So let's fold this from bottom to top. Now you can as well do it from top to bottom. Now if you do it from bottom to top, then you are going to have something like this, because the negative y-axis is going to fold onto the positive y-axis. And then you have this to be the positive side, and then this is also going to fold onto this side. So once you are able to fold along the y-axis and also along the x-axis, so long as the graph folds onto itself, then we say that this is an odd function. Now, one other important thing we need to also discuss is the fact that there are some trig functions that can either be even or odd. Now let's talk about first the even trig functions. So for even trig functions, we have cos x, and then we can as well have sec x. Now for the odd trig functions, we have sin x, tan x, cosec x, cot x, and so on and so forth. We can also have functions that are neither even nor odd. Now a function is said to be neither even nor odd. Now a function is said to be neither even nor odd. A function is said to be neither even nor odd if f of negative x is not equal to f of x, or f of negative x is not equal to negative f of x. Now if f of negative x is equal to f of x, that is an even function. If f of negative x is equal to negative f of x, that is an odd function. But if f of negative x is not equal to f of x, neither is it equal to negative f of x, then that function is neither even nor odd. Now the only function that is even, and odd is the function f of x equals 0. That is the only function that is even and odd at the same time. So let's try these together. Determine whether the functions below are even, odd, or neither even nor odd. So let's solve this together, starting from 1. So let's say we have f of x equals x squared sine x. Now we are going to investigate whether this function is even, odd, or neither even nor odd. So first of all, let's plug in negative x wherever we see x in this function. So let x equals negative x. So we have f of negative x equals negative x square sine negative x. Now let's simplify this expression. So negative x square becomes x square, and then sine negative x becomes negative sine x. Now let's multiply these two, and then we have negative x square sine x. Now x square sine x is equal to f of x. Therefore, we have f of negative x equals negative f of x. Now, since f of negative x is equal to negative f of x, it follows that f of x, which is equal to x square sine x, is an odd function. So this function is an odd function. Now let's move on to 2. So we have f of x equals x square minus 2 divided by x into brackets 1 minus x square. So let's substitute negative x in place of x. So f of negative x is equal to negative x square minus 2 divided by negative x into brackets 1 minus negative x square. So let's simplify. Negative x square becomes x square and then minus 2 divided by negative x into brackets 1 minus, now negative x square is x square, so this is minus, and then this becomes x square. Now we can further simplify this as negative, so this negative comes here, negative x square minus 2 divided by x into brackets 1 minus x square. Now x square minus 2 divided by x into brackets 1 minus x square is f of x. Therefore, we say that f of negative x is equal to negative f of x. In that case, f of x, this is f of x, so this function is an odd function. This function, f of x, is an odd function. Now let's move on as we solve question 3. So for question 3, we have f of x equals x times the square root of the absolute value of x minus 1. So let x equals negative x, and then we have f of negative x equals negative x times the square root of absolute value of negative x minus 1. So we have negative x square root of, now absolute value of negative x is equal to the absolute value of x. So let's say absolute value of negative 2 is equal to 2, and that is equal to the absolute value of positive 2. So absolute value of negative x is equal to absolute value of x and then minus 1. So we simplify this as negative into brackets x times the square root of absolute value of x minus 1. And you realize that what's in the bracket is exactly what we have as f of x. Therefore, f of negative x is equal to negative f of x. Hence, f of x is an odd function. F of x is an odd function. Now let's move on to question 4. That is f of x equals ln into bracket tan x minus e exponent the absolute value of x. Now let's try this question. So let x equals negative x. We have f of negative x equals ln into bracket tan negative x minus e exponent negative the absolute value of negative x. So this becomes ln, we have negative tan of x minus, now the absolute value of negative x becomes absolute value of x, and then we have this to be ln of ln into bracket negative tan x minus e to the power absolute value of x. Now looking at f of x, you realize that what we have here is not exactly as what we have as f of x. So since f of negative x is not equal to f of x, it means that this is not an even function. Secondly, you realize that here we have the sign to be positive tan x, here it is negative tan x, this is negative e to the power absolute value of x, and this is also negative e to the power absolute value of x. Now since both signs do not switch, it means that this cannot also be an odd function. Now for an odd function, if this becomes negative, then it means this becomes positive. However, this is positive, this is negative, it changed. However, this remained the same, therefore it cannot be an odd function. Therefore we say that f of x is neither even nor odd. This function is neither even nor odd. Now let's move on to 5. That is the function f of x equals e to the power x squared minus 1 plus ln into bracket absolute value of x plus 1. Let x equals negative x, we have f of negative x equals e to the power negative x squared minus 1 plus ln absolute value of negative x plus 1. Now negative x squared is x squared and then minus 1 plus ln absolute value of negative x is equal to absolute value of x and then plus 1. Now this expression on the right hand side is exactly what we have as f of x. Therefore f of negative x is equal to f of x. Hence f of x is an even function. So let's move on to periodic functions. A function is said to be periodic if it repeats its value after every particular interval. Now a function f is said to have a period t if f of x plus t is equal to f of x, where t is not equal to 0 for all x be a member of the domain of the function. Now what this primarily means is that the function f repeats all its values after every interval of t. That is the explanation to that. Now to calculate the period of a function, basically we are going to use the formula derived from the basic sine and cosine equations. Thus, f of x equals a sine bx plus c plus d, or better still, a cos bx plus c plus d. Now a is the amplitude of the signal, c is the phase shift of the signal, and then d is the vertical shift of the signal. Now the period of the signal, which is represented as capital T, is equal to 2 pi divided by the absolute value of b. So basically, this is where our interests lie. To find the period, we are first of all going to find the value of b, and that is equal to 2 pi over the absolute value of b. Now, having this in mind, let's try these questions. So for a, we have f of x equals sine 2x. Now we can represent this function as 1 times sine 2x plus 0 plus 0. Now comparing these two equations, you realize that b is equal to 2. So we say that b is equal to 2, and then to calculate the period is given by 2 pi divided by absolute value of b, in this case absolute value of 2. So we have 2 pi, absolute value of 2 is 2, 2 cancels out 2, and then we are left with pi. Therefore, the period of the signal or the function sine 2x is equal to pi. Now let's move on to b. We have the function g of x equals cos negative 2x plus pi on 3. Now from observation, you also realize that the value of b in this signal or in this function is negative 2. That is the coefficient of x here. So that is negative 2. And then the period is equal to 2 pi divided by absolute value of negative 2. That is equal to 2 pi over 2. 2 cancels out 2. And the period is pi. Now to c, we have h of x equals x minus sine x. Now this is not a periodic function. This is not periodic. Now the graph of this function looks like this. So this is the y-axis, this is the x-axis, and then you have the graph of this function as something like this. This function does not repeat its values at regular intervals. It continues on and on and on. Therefore, the function h of x equals x minus sine x cannot be a periodic function. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.